Okay. Good afternoon. Today we'll do two programs. One is called DFS, another one is called the Prim's algorithm. Prim's algorithm, already I told you algorithm, and today morning we had discussed about the DFS algorithm. We'll go a bit in detail how it will be working the program. So simple code I told around 6 to 7, 8 lines code other than the main program. Main program, you know that how to take it, and I told you to write draw the diagram spanning tree using DFS. So simple diagram we'll do it now. Then we'll move to the programming. So here, before going there, we'll write it how it will be taking the input values and how to enter it into the through computer. Let me take the values here. Suppose if you take A, B, C, D. Write the diagram DFS. Right. Now I'll call one Deepika. Deepika. Deepika.
Yes, sir.
You're here only, not sleeping.
No, sir.
Right, madam. So now, tell me how many nodes are there?
4 nodes, sir.
Yeah, n is equal to 4. Now you have to take the cost matrix. Let me take 2 arrays. Let me take 10 by 10 matrix. Okay. Now tell me the matrix. A to A. Matrix.
0, sir.
A to A 0. A to B.
1.
A to C.
1.
A to D.
1.
B to A.
B to A 1.
Huh?
B to A 1, sir.
B to B.
0.
B to C.
1. 0, sir. 0.
B to D.
1. C to A 1. C to B 0. C to C 0. C to D 1.
C to D 1.
1. D to A 1.
D to A 1.
D to B 1. D to B 1.
D to B 1. Door close ಮಾಡ್ಬಿಡಮ್ಮ. Hello. Door close ಮಾಡ್ಬಿಡಿ, sound ಬರ್ತದೆ. Next D to C.
D to C 1.
D to D.
D to D 0.
So these were the matrix. Okay. Now for this you have to write the program. How many nodes are there? What is the cost of the matrix? And you have to do the values. So you have to give the input values. and you have to write the start of where to start. That one normally we'll start the starting node. So normally we'll write this is called first node, second node, third node, fourth node. So for our understanding purpose. So suppose if you give the starting node is 1. Starting node is 1. If you take, what will happen? So can you tell me the spanning tree? Yourself only.
Yes, sir.
Deepika. Tell me, madam. So starting node is A means, tell me the DFS diagram spanning tree, tell me.
A to B, sir.
A to B, very good.
Next, B to C.
B to?
C.
B to C na?
C, D, sir.
D, right, madam. Next.
C to D.
D to C you have to say, not C to D. You are moving
Okay, sir.
where you have ended, from there you have to take it. So in terms of the output, what you will be getting is, so you are not drawing any spanning tree there, just you are telling the answers. So 1 to 2, graph is 1 to 2, next is 2 to 4, next is 4 to 3. This is what you have to get the output. 4 to 3. This is what you have to get the output. Now for this you have to write the program. Now you have how many nodes are there? How many nodes are there?
4 nodes.
4 nodes are there. So how many edges are there in the spanning tree?
3.
3 edges. So whether it is from A to B, C, D, can you reach it? From A, can I reach A to B, A to C, A to D from starting node A?
No, sir.
From A, cannot reach C?
No, sir.
So I'll say yes, I can reach A to B, I can go B to D, D to C, I can go A to C, I can reach. I have
Because,
told connection is not there, but I can reach, no?
Yes, sir.
A to D? Can I reach?
Can reach. Yes, sir.
A to B also reach. Now how many nodes are there? 4 nodes are there, 4 link is there. So now the question says is nothing but, see here, the question is, check whether the graph is connected or not using the DFS method. Now what they are saying is, this is what A. Well, now this is graph is connected or not, you have to say. How many nodes are there? 4 nodes are there. 4 you have drawn. All is connected. So graph is connected. Graph is connected. Now, Deepika, you tell me for this, A, you have B, you have C, you have D. No. I'll rewrite this. A, B, C, D. Tell me for this cost matrix, Deepika.
Yes, sir. A to A0, A to B0, A to C1, A to D1,
right.
B to A0.
All zeros only.
Yes, sir. C to A1, C to B0, C to Z0, C to D1, D to A1, D to B0, D2C1, D2D0.
Right. So these were the matrix. Now, if your starting node A means the spanning tree will be coming like this: A to C and C to D, isn't it? Now B is there. Now, how many nodes are there?
4 nodes.
How many edges are there in a
2
spanning
edges.
tree? This is called spanning tree now.
2 edges, sir.
So these also called spanning tree. Right. So now, when you have the spanning tree, 4 nodes means how many edges should be there?
3 edges.
3 edges. But how many edges are there here?
2 edges, sir.
Edges here too. But in this case, edges 3. Correct now. So 4 nodes is
Yes,
4. In this case, nodes are 4, edges are 2. But this is whether the graph is connected all the nodes.
No, sir.
No, graph is not connected. Output should be graph is not connected. Now, any doubt for others?
No, sir.
Not Deepika, others also. Anybody is having doubt this? How to write the cost of the matrix? How to draw the spanning tree? Morning have given still bigger problems. With this, I will be writing the code for this. Simple, just 5 to 6 lines are there. Now we'll see how it will be working this code. Now, using DFS method, whether the graph is connected or not, we need to find out. So let us find out now whether the graph is connected or not. So now, directly I will show it. Gedit program question number 7, I hope. Not 7, 8. Nine. Right. So program number is 9. So now what I told you is enter how many number of the nodes. So Deepika only can continue now. First diagram, if you see here, I will show it parallelly. Right. So in this case, how many nodes are there? 4 nodes.
4 nodes.
Yeah, enter the number of the vertices or number nodes, whatever you want, you can enter. It is left to you people. 4. That's what you know how to take the input values, n values. That is nothing but this scanf percentage dn. Now what I do is, so here is for I is equal to 0, I less than n, I plus plus, have taken reaches of I is equal to 0. Initially, you are starting with A, I have to reach B, next to C, next to D. So to reaches initially for one more array I have taken, that is called the initialization is called 0. Next, enter the adjacency matrix. Now you have to enter the matrix for either you what you told 0, 1, 0, 1, 1, 1, 0, something like this. So that you have to take it. For I, you know that matrix how to take it. For I is equal to 1, I less than or equal to n, I plus plus, j is equal to 1, j less than or equal to n, j plus plus, scanf, address location of A of I comma j. So you can take const or I, whatever you want, you can take it, no problem. Next, once you take this DFS of 1, so that is nothing but the starting node you have given. So here is, it doesn't mean that you have to enter only 1. You can enter any node. There is no restriction in this, but normally we'll enter first. But when you are running the program, you can enter 2, 3, 4 also. So it will start from there and it will be working according to that, whether the graph is connected or not. So I'll show you the example also how it will be working. So now up to here is the input. So once you call this function, remaining is output. So I told you here it should display 1 to 2, 2 to 4, 4 to 3, how to display it. For that, this one. So that I'll come back last. So now when you are calling DFS of 1, now come back to here, DFS of 1. So that is nothing but the vertices. So vertices 1 you take, what will happen? Reaches of V is equal to 1. That means what? First node is visited. So here you can see it here. A node is visited. So A node is visited means first node is visited. So like this, you have to visit 3 also, 4 also, 2 also. If you have n numbers, n minus 1 nodes should be visited. So 1 already had taken. Out of n, 1 is subtracting. N minus 1 nodes you have to take it. So here is, now what I have to do is, just listen here, simple. This is nothing but visited node is made it 1. Next, here is visited is nothing but V, that is nothing but the starting node is called 1. So 1 to 1, 1 to 2, 1 to 3. So that means 1 to 1 is already visited, no problem. So here is next 1 to 2, 1 to 3, 1 to 4, you will check it. Now what will happen when you are drawing 1 to 2? Here, can you able to see the matrix? Students, can you able to see the matrix?
Sir.
Yes,
Hello. Sir. Can you able to see the matrix?
Yes, sir.
Yeah.
Yes, sir.
So I'll write it here. 1, 2, 3, 4. Here also 1, 2, 3, 4. So here is when you take 1, 2, 3, 4, 1 to 1, 1 to 2, 1 to 3, 1 to 4. So wherever you have 1, so 1 to 1, 0. So that is not considered. Actually here reaches of I, not reaches of I is nothing but what? Initially what will happen? Reaches of 1, 2, 3, 4, 0. So first when you are making here reaches of 1 is nothing but 1 you made it. So that is nothing but the 1. Reaches of 1 is called 1. So 1 naught is nothing but 0. So this 0 is not considered. Next when you come to the V 1 to 2, 1 to 2 is nothing but A to B. So that is nothing but A to B. Here connection is there 1. Now reaches of I value is nothing but 2. So reaches of 2 is nothing but 0. 0 negation is nothing but 1. 0 negation is nothing but 1. Otherwise this statement you can write it the another way also. Reaches of I is equal to 0. If you get confusion this, you can write reaches of I is equal to 0, this statement. That I'll tell you now. So next is, if it is that case, that is nothing but 1 to 2 is condition is satisfying, it will go inside printf percentage d, percentage d, percentage d. That is nothing but b is nothing but 1, and here I is nothing but 2. So 1 to 2 is printing, again calling the same function dfs of I. That's all your program. So 1 to 2, next start from the 2. So that means what? When you are drawing the spanning tree A to B, you have drawn. Once you drawn B, then you have to start from there only. So that is the reason after printing 1 to 2, then you have to call the function directly. So once you call this, it will move to the again the same program, same function it will go, again do the same thing. So 2 to 1 already reached, 2 to 2, 0 is there, not possible, 2 to 3, 0 is there, not possible, 2 to 4 is possible in this matrix. So here 1 is there, see here. Here 1 is there. So next reaches of I is nothing but reaches of 4. So reaches of 4 already 0. So then it is possible. So then printf. So that is nothing but the B to 4 is possible. That is nothing but B to D. That is nothing but 2 to 4 is printed. Once it is printed this, then we start from the again from 4. So again check from 4 to 1, 4 to 2. 4 to 1 is nothing but 1 is there, but here reaches of I condition will become false. Then we'll move to the second one. So second one is nothing but already visited, so that is nothing but that is also false. Next 4 to 3, 1 is there, 4 to 3 is not visited. In this case, that is called reaches of I is 0 will be there, 0 negation is nothing but 1. So there also condition is satisfying. This side also 1 and this side also 1. So then print it, that is nothing but the 4 to 3. So this is what the way of printing the DFS diagram. Now simple code. So here is, you have to take reaches and I is equal to 1, I less than or equal to n, I plus plus. So I told you this statement can be written like this also. So which one you feel easy, you can write it. It's left to you people. Control C, Control V. If you feel difficulty, reaches of I equal to 0. Anyone is possible. So reaches of I is equal to 0 means that is also possible. Otherwise, not reaches of I. So meaning you have to think in deep. That's all in that case. So anyone is possible. Both are correct. If you want to use this statement or this statement. Now tell me any statement is difficulty you are having. So now I'll tell you the code. See here. Now I'll close the program also, minimize it this. Alright. So now when I'm taking this, what will happen? Main program how to take, enter the nodes. Next is for I is equal to 0 to n. So that is nothing but reaches of I is equal to 0. Next, you have to take the cost matrix for this. Next is for I is equal to 1, I less than or equal to n, I plus plus. J is equal to 1, j less than or equal to n, j plus plus. Next is scanf percentage d address location e of I comma j. Next d of I. You have to call the function. Once you are calling the DFS of function, then what you are doing is reaches of v is equal to 1. So that means what, whenever you are calling that function, that will be adding 0. So once you do this, reaches, if you are making, then for I is equal to 1, I less than or equal to n, I plus plus. Next is if a of I comma j, and actually the statement you can write it like this also. I'll show you 1 second. Here, if you feel difficulty this statement, I'll write it this way also, equal to 1 and this should be 0. So if you want this, what will happen? This v of I comma is 1 and this also 1. Both are true, then it will be going here execution. Otherwise, this should be 1 and is equal to 1. So you make even 0 negation is nothing but 1 only. It will become 1 and 1 will be true. Here it will be working. So it's left to you people. You can be able to write this or this. So those are having knowledge. You want to minimize this, you know, and condition how it will be working. That you have to write the same way. So now I'll go to the scribe. I'll tell you the remaining code. So what I told you, for I is equal to 1, I less than or equal to n, I plus plus. If a of I comma j is equal to 1 and reaches of I is equal to 0, then print the source to destination. Source is nothing but v and the destination is nothing but I. Then call the same function to other in the same only. So you have to write the same function. That's it. So any doubt if you are having, please let me know this. Any doubt? Any doubt this? Shall I write the code once again? If you want to write, I'll write it. I don't have any problem to write. Just see, I told you 6, 1, 2, 3, 4, 5 lines. That's it. Including declaration 6. 1, 2, 3, 4, 5, 6. 6 lines of the code DFS program. So easiest program in Adalab. That's what I feel. Right. Any doubt now? Others? You have to say. Any doubt?
No, sir. No, sir.
Yes. Now, this is nothing but after this, how many edges is nothing but here 4 and edges is nothing but 3. Here edges are 4, nothing, nodes is nothing but 4, edges is nothing but 2. So graph is not connected, graph is connected. So now how to write that output is nothing but I'll tell you. That is simple concept. After this, what you have done is I is equal to 1, I less than or equal to n. So if reaches of I, so in this case, if reaches of I is nothing but what will happen? In this case, reaches of 1, reach of 2, reach of 3, reach of 4. So 1 is made it 1, initially 0, initially 0, initially 0. So this you are making called 1, and 2 you are not touched, so you are reaching to C. So that is nothing but the, what will happen? Here you make it as 1, and D in this case, next will be visiting, this you are overlapping to 1. So now what will happen? Now come back to the program here. What have written? I is equal to 1, I less than or equal to n, I plus plus. So 1 count is equal to 1. Next is 2, this will not be added. Next is I is equal to 3, count will be 2. Next one is nothing but count is equal, I is equal to 4, count is equal to 4. In this case, you are getting 3 only. So what will happen? Count is equal to how many number of the nodes. So here count is 3, number of nodes is nothing but 4. So here you can see here, so count is equal to 3, number of nodes is nothing but 4. So 3 is equal to 4, no, the graph is not connected. But in this case, 1 also visited, 2 also visited, 3 also visited, 4 also visited. So 4 is equal to 4, and number of size nodes is equal to 4. How many nodes you have visited also, reaches also 4 only. So that is the reason here the graph is connected and graph is connected. See here, count is equal to n, graph is connected. Else graph is not connected. Any character, if you are having doubt, please let me know this. So why you are using reaches of I is nothing but to say that because of the program bit they change it. So whatever we are doing in the theory bit different way, and here whatever we are doing the different way. Say there is nothing but, so we are drawing the spanning tree, that's all. So whether the graph is connected or not, we are not bothering in theory. But here just a small modification they have asked whether the graph is connected or not. So that is what we have to check it out here. Now please tell me, do you have any doubts, any statement? I'll tell you. Any statement you have doubt? Okay. So here is, students, some of the people common mistakes. These two variables, whenever you are using the recursive statements, we cannot use declare as a global variables, because whenever you are using the recursion, because stack concepts will be working, that's what I told you morning. So how the stacks values will be adding and decreasing. So if you are using normal variable declaration, so values will be updated, the previous values we cannot take it, but in the stack you can get it, because you are storing there, that is called temporary memory allocation. It will be popping out. When it is popping out, you can be able to find out the values. That is what you have to check it out. Now we have to run the program and we have to show it. Now the first program, whatever you have told here, so this is nothing but this matrix. I will enter it and then we'll check it out whether the program is working or not. See here, CC PROG 9.c. So there is no errors. Now dot slash a dot out. Right. So number of vertices is 4, and Deepika.
Yes, sir.
Tell me
Yes,
the
sir.
matrix. Do you have the matrix?
Yes, sir.
Tell me 0, 1,
1 1
1 1. Next
1 0 0 1.
All right. Next
1 0 0 1.
Next
Triple 1 0. Triple 1 0.
See, you have to examination, you have to write this matrix. Then, first you have to write the diagram. Next, you have to write the matrix. Then you have to write the answers here, whatever you are getting. So without writing this, don't enter in examination. Simply 1 2 1 2 1 2 and all. Now starting node is nothing but 1 only. Have entered it. 1 to 2, 2 to 4, 4 to 3. So whether you got it or not, check it out in this case. What I have told you, 1 to 2, 2 to 4, 4 to 3. So now see here, what you got here, 1 to 2, 2 to 4, 4 to 3. What Deepika, what you told, you got it or not?
Yes, sir.
Now graph is connected. Answer. So you can give /n, we'll move to the next line. Now second matrix you are having now. So tell me the second matrix also. I'll show you now. So you have to enter both graph is connected and graph is not connected. Tell me that one. 0.
Double 1, double 0,
double 1. All right, madam. Next.
Double 0, double 0. 1 double 0 1.
1
double 0 1.
1 second. No? Right. Next.
1 0 1 0.
1 0 1 0. What answer you got it? You can be able to reach us 1 2 3 3 to 4. That's what we got it now. So see here also I'll show you 1 2 3 3 to 4 you got it. So other value, that's all you can be able to reach it. 1 to A to C I can reach, from C to D I can reach, but I am not able to reach the other node that is called the B. So that is the reason this one is graph is not connected. So whatever you have given the graph, that is one node is not connected. That is the reason you have displayed it called the graph is not connected. Okay, is it clear now? Program, right?
Yes,
so now you can copy the program. Right, copy it properly. Indentation also write it separately. Under for if statement is there, under this one. So this comment line I have put it just for understanding purpose. So matrix anyway you are reading here. So const of A I comma J, 1 to 2, 1 to 2, 1 to 1, 1 to 2, 1 to 3, 1 to 4 you are checking. So you can be able, this should be 1 and reaches should be 0. That's it. So then it is possible to print it and you can call the same function once again. That is the reason I've written that one. So both our statements are right. Which one you want, you can use. You can copy it and tell me, then I'll drag it, then I'll move to the next program. Copied? Hello? Deepika? Copied?
Yes, sir.
So let's scroll down. What about others? So int main already have written, and after written only closing bracket. Once you complete this, tell me, then I'll move to the Kruskal's algorithm.
Yes, sir. Yes, sir.
Sir, 1 2 ಬೇಕಾ? ಲ್ಯಾಬ್ ಇದೆ, ಆಮೇಲೆ ಕಲಿಸ್ತೀನಿ. ಲ್ಯಾಬ್ ನಡೀತದೆ ಸರ್, ಕಲಿಸ್ತೀನಿ. ಅದೇನು ಓನ್ಲಿ ಕ್ವಶನ್ ಪೇಪರ್ ತಾನ? I'll send it, sir, no problem. Murali Krishna completed?
Yes, sir.
Have you completed the code?
Yes, sir. I have written, sir. Complete code I have written.
What about others? Anybody still writing? Anybody still writing? Anybody is writing still?
So no, sir.
Huh?
No, sir.
Okay, over. I'll move to next one. So next one is find the minimum cost tree spanning tree given undirected graph using the Kruskal's algorithm. Prims already you have done it because there was written the questions zigzag. Actually, Prims Kruskal's 1 unit, you see the Kruskal's is 8, they have given, Prims is nothing but the 12th they have given. So that is where the problems. So okay, anyway, no problem. So we'll go according to the syllabus. So Kruskal's algorithm is nothing but the 8th program, and already you have done it this. So just I'll tell you the simple Prims you have done it the similar way here also you are doing.
Sir.
Right.
Hello, sir.
All right, sir. Tell me, sir.
Present the screen, sir.
Huh? Screen is not visible?
No, sir. It's off.
No, sir.
1 second, 1 second. Copied all of you this. Shall I move to Krishkal? Right. So I'll move to the Krishkal. Already because you have done Prims, so just 5 minutes it will take, not more than that. I'll tell you that also. So now just see the code, all of you. Just I'll not take much time here because Prims you have done it the similar fashion. So there you are starting with first node, but here based on the cost you are taking. This is still simple. So now enter the number of the vertices. This is same, either cost matrix without cost matrix. So take how many number of nodes. Next you have to enter the cost matrix. So 1 second. First I'll enter one graph. Then we'll move to the next one. This is nothing but C here. Now anybody can say the spanning tree for the cost matrix for this. A to A is 0, A to B is 4, A to C is 3. I want to tell it. B to A 4, B to B 0, B to C 2, C to A 3, C to B 2, C to C 0. So these were the matrix. Now for this spanning tree is nothing but the minimum is nothing but first A is there, B is there, C is there. Now what? See, without writing also it is coming. Okay, so A, B, C. So the minimum cost spanning tree is nothing but B to C is the minimum. That is nothing but first one to be drawn, T. So A to C, next 4 is there, 3 is there. The minimum is nothing but the A to C. That is nothing but the 3. So now minimum cost is nothing but, the answer is nothing but 2 to 3 is called 2, 1 to 3 is nothing but 3. The minimum cost is nothing but 2 plus 3, 5. This is what you have to get the answer. So 2 plus 3, 2 to 3 is 2, 1 to 3 is nothing but 3. So 2 plus 5 is nothing but the minimum cost is nothing but the 5, you have to get it. So now for this, now how many number of the nodes, and you have to enter the matrix. See here is, that's what I have done it. I is equal to 1, I less than or equal to n, I plus plus, or j is equal to 1, j less than or equal to n, j plus plus, and scanf cost of I comma j is equal to 99. What I have done is, if cost of I comma j is equal to 0, so that means what? Here this is nothing but 0, you have to make it called 999. So that means system will be taking, you enter 0 only. Once you write the statement, it will be taken called 999. So that, because what will happen if you are not entering 999, what will happen? 0, 4, 3, which is the minimum, means 0 will be taken. So that is the reason to make infinity, because we cannot make infinity in this case. So that is the reason we are entering 9999. So another one is, now if you take it 99943, which is the minimum, is 3 will be the minimum. You can find out easily in the first one. So now come back to the program here. So that's what, once input over. Now how many number of edges less than n? So here is, you have 5 nodes, means 4 edges, you have to get it. So here is I is equal to 1, same whatever you have done the Prim's algorithm. Minimum is equal to 999, I less than or equal to n, I plus plus. So for j is equal to 1, j less than or equal to n, j plus plus. If cost of I comma j less than minimum, at least there one more statement we have written extra, but here nothing is there. So entire matrix, which is the minimum. So if you see here the matrix, so you are assuming 99 is the minimum, next 4 will be the minimum, next 3 will be the minimum. We're reading this 4 also reading, to 0 also reading, 99 also reading, again 2 will be the minimum. So here also same thing, here also same thing, here also same thing. These two you got it the minimum values. So once you get the 2 is the minimum, that is nothing but 2 to 3. So now see here, once you get 2 to 3, minimum is equal to cost of I comma j, a is equal to b, u is equal to I is equal to b is equal to v is equal to j. So that means what? A and b values, you are writing source and destination. So here in this case, source and destination is nothing but, which is the minimum, means b to c. That is nothing but 2 to 3. So that's why the first statement 2 to 3 is nothing but 2. So that's what you have written it here. Now what you have to do is, while parent of u is equal to u of parent of v. So that means what? U and v make it equal. So that means what? So parent of v is equal to v and parent of v. So here is, so you are making call the this values to assign to the u, so that you will be getting the reaching the same node. So next what will happen? This both are not equal. So u and v is nothing but the different. So if u and v is different, printf percentage dh, that is nothing but the 2 to 3, you got it. So first one is called the ne plus plus, is nothing but the first one. Next is a is nothing but 2, b is nothing but 3, the minimum cost is nothing but 2. So that's what here. First here you will be getting the answer something like this. First one, 8, edge, and you will be getting the tab of 2 comma 3. So that means what? So space will be given 2 comma 3, that is nothing but 2. So that is what you will be getting the first answer. Second one is edge. So you have 1 comma 3, that is nothing but the 3. So like this, you will be getting the answers. So once you get this, what you have to do is cost of a comma b, cost of b comma a. So that means what? This once you made it 999. So just to see here, so that means what? This value and this value, once you write this, both values you have changed it to 999. See here, that's what this. So this also 999 and this also 999. So that means what will happen? So these two you are making both are 99. So that later stages when you are coming to the next statement, next while loop, it will not be considered these two values. That's what this statement. Cost of A comma B, B comma A. Remaining is same one. Compared to Prim's also, Kruskal's algorithm is simple. This is what one step. The remaining you give any big number of diagrams, so system will be taking care. So like this, how many nodes are there? How many edges? So yeah, one edge should be less than that. Suppose if you are giving 5 nodes, 4 edges should be there. So that's what will be taken this statement. As it is, still simple compared to the Prim's algorithm. Now I will run and show you the same diagram, whatever I have written it here. So you can show it here now. So now CC so no errors dot slash A dot out. So number of vertices is nothing but 3. So same matrix only I will enter it here. Whatever I have entered it here, the same matrix I will enter it here also. So that is nothing but the 0, 0, 4, 3. Another one is called 4, 0, 2. This is nothing but 3. This is nothing but 2. Another one is called 0. So now you can see here the same matrix I have entered 0, 4, 3, 402, 320. 402, 320. So that is what the matrix I have entered. So now what you got is nothing but 1 to 2 graph is connected. Somewhere went wrong. I'll check it out. Right. Enter it because it is copy paste is not taking here. Copy paste is not taking. I'll enter it once again. So number of vertices is nothing but 3, 0, 4, 3, 4, 0, 2. Another one is called 3, 2, 0. So now I'll show you here. Right. Now you can see here, that's what I wrote. One first edge, 2 to 3 is nothing but 2. Second edge is nothing but 1 to 3. That is nothing but 3. Total minimum cost is equal to 5. So like this, you can enter the bigger program also. You can check it out whether your problems is right or wrong. Now I gave the homework for you to practice in theory. That is called one Prim's algorithm and one is called the Kruskal's algorithm. So one Prim's and one Kruskal's algorithm, whatever you have done it and whatever I have done in the class, you check that whether it is right or wrong. You can check it out. Through programming, you can check it out whether it is right or wrong. Okay. So now I'll move to the program. You can check it out. Right, you can copy it now. Program code is simple. You should not get confused. What is input, what is output, what is the logic. Algorithm, you know, and problem, how to solve it, you know. Once you know how to solve the problem, the similar concept. You know matrix, how to take the similar fashion only here. So from graph, how to draw the matrix also you know now. With cost also today we have discussed, without cost also we have discussed. How to enter the cost of the matrix. And copy it now. Can copy, you can wind up. So have send it one Google sheet, you fill it that and you send it back. All of you got it?
Yes, sir.
MCQ questions have sent it, do you got it?
Yes, sir. Yes, sir.
Yes. Simple questions only, fill it and send it. That also basics only have given. Copied this.
Yes, sir.
Shall I scroll down? From while I will keep it. ಬಾ ರಾಕ್ಷೇವನಿ ಮೇಡಮ್ ಏನ್ ಮಾತಾಡ್ತೀರಾ ಮೇಡಮ್, ನಿಮ್ದೇ ವಾಯ್ಸ್ ರೆಕಾರ್ಡ್ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ.
Sir, about
Yeah,
lab
yeah.
internals,
Complete
you will
this.
tell. Sir,
Once
about
we
lab
complete
internals,
this, end of the
okay.
session, I'll tell you, end of the class. Copied properly, indentation also write the same way. You need to understand, suppose if you are seeing here if statement, under if this statement, under while what all the statements are there, under this if statement what is there, under this while what is statement is there, under this while statement what is there. Everything you write it very clearly. So everything if you write it leftmost indentation, it will be difficult for you to understand later. Completed? Naina, completed? Murali Krishna, completed?
Yes, sir.
So another 2 lines also completed. So by that time I will take parallel attendance. Answer attendance 1. Register number 1. Morning was absent. 2.
Yes, sir.
3.
Present, sir.
4.
Yes, sir.
5.
Present, sir.
6. 6 Arbas. 7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12.
Present,
13. 13. 14.
14, present, sir.
13. Debmalya. 16. Deepika.
Present, sir.
17.
Present, sir.
18.
Present, sir.
19. 20.
Present, sir. Present, sir.
21.
Present, sir.
22. 22. Jinjar Singh. Absent. 23. Kavya. 24.
Present, sir.
25.
23, present, sir.
Right, madam. 26.
Present, sir.
27.
Yes, sir. Present.
28.
Present, sir.
29. 29. Nilanjan. 30.
Present, sir.
Register number 2. TD series.
Present, sir.
3.
Present, sir.
4.
Present, sir.
5.
Present, sir.
6.
6 present, sir.
7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11.
Yes, sir.
12.
Present, sir.
13.
Present, sir.
14.
Yes, sir.
16.
Present, sir.
16.
Present, sir.
17.
Yes, sir. Sir, 16,
18.
present, sir.
Right, madam. So 18. Spurti. 19.
Present, sir.
21.
Present, sir.
Sir, 20%.
Oh, right. 22,
Present, sir.
23. Right. So all of you copied the code?
Yes, sir.
Yes. So you have to practice. Then only you will understand. So you have online compiler, otherwise ordinary C++ software also okay. So type it, execute that one, whatever you have done in the class, that program also you check it out whether you are getting right answer or not. Okay. So you know how to write the cost of the values, I mean matrix, how to write it, cost of the matrix, how you know how to write it. From that minimum cost spanning tree, how you are getting also you know that, but finally answer you check it out whether it is right or wrong, minimum cost spanning tree. So that is what you need to do it. And coming to the lab internals, I have done in linear search, binary search is one program, mud sort, quick sort, insertion sort, next is prims, crystals, and DFS. I hope 7 programs we have completed. All 7 programs will be there for internals. Okay. So I'll tell you once again. Question numbers, you check it out in your syllabus. Binary search, linear search, mud sort, quick sort, insertion sort, prims, crystals, and DFS program. This is what first 3 units laboratory programs. This is what will be there for the test. Okay. So first I'll be sending MCQ questions, 10 marks, 10 questions will be sending, 10 minutes will be given, that's all. So I'll be set the time, so I'll disabling. So you'll be ready for test at 1:45 exactly. So once it is completed for MCQ test, then I'll be telling the question numbers, then you have to write it and you have to upload it. Then I'll be asking 1 or 2 questions based on that. So then we'll wind up. Okay.
Okay,
So you should know every program, all 7 programs you learn it, and what is the input values, output values. Suppose if I am giving one diagram for prims, if you are saying minimum cost spanning tree exactly, then only you will get full marks. Otherwise, no. All marks it's in your hand only. Suppose if I am saying insertion sort, some numbers I will say. If I say the 4th iteration, what will happen? That iteration only have to say it. Quick sort, if I say some numbers, I will give it. What is the partitions will be happening first iteration? So that's what you have to say. So please practice all problems before coming for the examination. So next week all marks is in your hand. Best of luck. Shall I close?
Yes, sir. Thank you.
Yes. So you have to practice. Otherwise, it is difficult. I'm telling you.